like an intro bit yet?
We don't. You keep saying the we're here to make you compliant with techno capital bit, and we can do that again, or I could say it.
I don't know. It's kind of like boring. It's kind of passé at this point. Like I don't know. Like it sort of just makes me want to like fall asleep.
Okay,
Honestly,
well, we have
I
the
like having the
welcome
same
back to
bit every
Beak to
single game.
Beak. Beak to Beak is pretty good.
Or what if this is like their first time joining us?
Then
Like they
you
would
could
need to
say
know what the
welcome
premise
back to Beak
is.
to Beak, or well, thank you for joining us on Beak to Beak. And uh, if you're new
Thank you for
here,
joining us on
I'm
Beak to
sorry.
Beak. We're going to make you compliant to Techno Capital, and if you're new here, we're sorry.
Yeah.
How's that?
Twin Peaks. You know it's time to get the lab coat on. Twin Peaks. Yeah. Cause we out here being hella wrong. Twin Peaks. And you know we're never stopping till the hammer drop.
I thought that was a good intro. What's the article we got today, Mr. Squid?
Oh, hold up. Wait, we don't have any background music playing. I think we should probably have that.
You can do that in pose.
I could,
Potentially.
but do I want to do it in post when I could just do it now?
Okay, yeah, I get it. You just want to drown me out. This guy wants to get monetized. This guy wants to get monetized. You're kidding me. Oh, hold up. Does this work? Oh.
That's a little bit much.
This guy wants to get monetized. That's what's going on.
Fuck off.
Mr. Salt trying to enter into the big marketable domains and get a little bit of that sweet, sweet ad revenue.
Hmm.
Ooh la la. What's the article we got today, Mr. Squid?
All right, today we're looking at an article from Nature Neuroscience, and it's called Falling Asleep Follows a Predictable Bifurcation Dynamic. And this is an article that is looking at different people's plane of falling asleep and what part of that entire path they actually lose consciousness, and trying to use EEGs and other tools to try and map out what point people are actually falling unconscious.
I like that you say map out. Yes, that's exactly what's going on here. Do you want to read the abstract? Because I think you described it pretty accurately, more
Yeah.
succinctly than the abstract.
Okay, we'll go through the abstract here. It looks like this was accepted and published in 2025, so it's pretty recent study at least. It looks like it was conducted.
We've only got hot off the press content on Beak to Beak.
All right, let's
like
get.
When our two beaks meet, it gets
Oh.
pretty hot off
Oh.
the presses.
Oh no!
Okay.
Listen, that is for regurgitation only, and that's a matter of survival.
Okay, all right, hold on, Salty. We got to do the bit. Salty, I thought you said that you ordered a hotel room with 2 beds. I only see 1 bed.
Well, I guess you're sleeping on the floor.
Bifurcation is actually a very important understanding for theory right now because of the climate. Where are you going to hear about tipping points? It's mostly the climate.
And
What are these
honestly,
what are these
for
tipping
people
points?
that have no like background in any of this, bifurcation is just a term that's used in systems and how systems interact with each other. It's mostly a physics and engineering thing, correct?
It's how the variables in a system interact with each other to bring about like quote unquote permanent, a quote unquote irreversible change, or like a sudden drastic shift in identity.
Yeah, I mean,
we
so
would-
the
we
way
would
that
have
this relates to
identity down here,
sleep,
and then this one here.
the way this relates to sleep is that you, as you're laying down and you're getting in your bed and you're closing your eyes and you're starting to slip into unconsciousness, that gradient is what they're looking at and they're mapping out as a path. From the time that you're
Correct.
starting to go to sleep to the time that you actually reach unconsciousness and all of the physiological things that go into that.
Correct. How did this paper do that? Would you mind? I think if you scroll down, I mean,
I've actually got some
honestly,
notes here on the methodology if you want me to just read what I've got.
Yeah, fill me in with what you're thinking.
So the methodology for this, which is again one of the most important parts of any paper because it tells you what the standards and what the tools they used were, and if that's
the
bunk,
objective
then
measurements.
yeah, if the methodology is bunk, then the rest of the fucking paper and the results are going to be bunk. But I think they did a pretty good job here for what they were trying to do. So the main tool that they used was the electroencephalogram, which is when they hook up wires to your head and try to capture your brain waves. They used 1,000 adults in the study, combined EEG features. They used those to create what they call a feature space, which is a representation of the journey from woke to sleep as a path. This allows them to calculate the sleep distance, i.e. how far someone travels down the path until they tip over into the sleep, which would be the state change that we're talking about in the bifurcation. And then the last thing I had was the saddle node bifurcation, primary mechanism for disappearance of steady states in dynamics and physics. So I guess the saddle node bifurcation would be when your steady state is disappearing into a different state.
Yes. So, I mean, if you imagine a saddle, like, there's sort of like a nice equilibrium point in the very middle, but you can fall off either side.
Yeah.
At that middle point, with like a little nudge. You actually summarized, I thought, the methodology very succinctly. Yes, they used an EEG to measure the brain waves. Actually, hold on. There's one detail that you omitted. There's two parts of this paper. The first part, they generated this bifurcation model based on data from other people's experiments, primarily from old people. Like about 1,000 old people is what they used to generate the model. And then they attempted to disprove it in another population with about 200 people. There's something else. So they did have 1,000 participants, but those participants were from another study. They used that data to develop this model bifurcation. They then used this model, essentially reality tested this model bifurcation on 36 individuals in their own experiment. That's the big thing in your explanation.
Got it. So yeah, they didn't actually test the 1,000 adults themselves and hook them up to wires. They only did that to 36 people, but they used the data from other EEGs to build the paths.
Correct. Very correct.
I'm such a smart boy sometimes.
It is. I'm not gonna lie. You kind of do put a couple of things together every now and again. It's kind of crazy.
Sometimes.
You restore my faith in humanity.
Aw. That's cute.
Well, you're a squid though, so.
Yeah.
I guess you're the one like ruling over humanity, so maybe there's like.
The cephalopods will rise.
Yeah. Okay. So the article actually has their own explanation for bifurcation, specifically in the domain of sleep. They say that there are going to be a variety of variables which come together to generate an unstable equilibrium which annihilates the former variables and establish a new regime. This regime is considered generally a hysteresis or a crisis. So when we're talking about quote-unquote climate change, as the wokies call it, tipping points would be something like the Atlantic Meridian Oceanic Current. It would be something like the Thwaites Glacier. It would be something like the Amazon rainforest. It would be something like.
Can we apply this
to? It would be like the pH of the ocean.
Can we apply this to animal populations in an environment?
Yes. So, animals, when an invasive species is introduced into an environment, they follow not quite a bifurcation model, but like the math is relatively similar, where like there's sort of a slow build-up and then like it explodes and then levels off essentially. And that's actually where like the math behind this was developed, was ecology and population studies.
Nice.
Yeah, so I mean, you're like right on. But hold on, let me continue with how they describe this. This will lead this system to have an abrupt, discontinuous transition to another state, sometimes also described as a catastrophic regime shift. The point at which this bifurcation occurs is also known phenomenologically as the tipping point, or the point of no return. A simple illustrative example would be bending a stick. And would you look at what I got right here? I've got their diagram. See illustration in figure S1. We start with no force and gradually increase our force to bend it. The stick will show minor deformation until at some point when the force is strong enough at the tipping points, the stick will snap, which is a catastrophic change into a new system state where the original state has disappeared. This is an extreme example where the transition is not reversible. In many natural systems, however, bifurcations are reversible. And they can follow a different return path, and that then leads to hysteresis. Hysteresis is the return to the former path and the repeat of like this instability. It's actually like, that's another thing for the theory. But basically, they've got arrows along this diagram here. So the system state refers to like consciousness. And the lower you go, the more unconscious you are. They've got two directions of attraction. The model that sleep is based off of is on the interplay between two things. This wakefulness parameter, hold on, I think I've got, yes. This wakefulness parameter, or the homeostatic influence, and then the circadian influence, or the sleep parameter. And when these two converge, along with exogenous stimuli like red light, blue light, the night to day cycle, then that's when you fall asleep. And their idea was, okay, people have been saying it's potentially a bifurcation model. And so what they wanted to do was test how robust that theory is by developing a model and then applying. What is a theory? A theory explains former observations and it explains future observations. Did they succeed? I'd say so. I also would say I don't have the expertise to genuinely criticize them on like an actually intellectual level of like the publishers.
Yeah, I mean, this is pretty outside my realm of science, but I mean, I still understand it.
Like whether or not sleep, quote unquote, meets all of like the criteria for a bifurcation math, whether or not they had the right statistics for each, I don't know.
Well, the findings, I can read off some of the findings if you'd like.
Yes, let's go into this onto the findings. How did they do it? What did they see?
So what they saw was that falling asleep follows a bifurcation dynamic like they thought it might, meaning it gradually changes to a critical point and then suddenly shifts states. Woke to sleep, unconsciousness. The brain slowly shuts down and prepares for sleep until it reaches a point of restfulness to cause a sudden shift into a state of unconscious. Each of the participants' sleep distance was relatively stable across multiple nights.
Yes. Okay, but I think you're getting ahead of yourself a little bit. I guess you've ejected ink before
I saw the predator.
Before you saw the predator? Yeah. Does that line up?
Yeah.
I'm sorry.
Yeah.
I'm not very. I don't know if that was insulting to like cephalopods or anything. But you're getting ahead of yourself a little bit. What they first did was they wanted to know whether or not their method of quantifying consciousness worked. So what they did was they took a bunch of known means of interpreting EEG data, temporal coherence, peak, alpha, beta, delta, theta band frequencies, the ratio of various to each other, and then also the direct bands, the delta, the theta, and the alpha and the beta bands. And then they used all of these to classify, this is, by the way, figure 1 on the left, figure 1A. they used this essentially noise and broke it down by the various features, and they used those features to compress everything into a single line. This is essentially what AI does. It takes the relationship between every factor and every other factor, or I guess in this case it would be, with AI, it would be every word to every other word. What AI does is it finds the next most probable word in the sequence. What their model did was, it finds the next most probable word in the sequence by narrowing everything down into one vector to find the next word, because you can't have multiple next words. It's only the next one, and then the next, right? Their model collapsed all these features into one score called, what was it called? What did they call it? Where is it?
You said I was getting ahead of myself?
Vector. It's the state vector, which they normalized because there can be variety between sessions, where the electrodes are placed. It can vary based on the person themselves. And they thought that this mapped onto bifurcation relatively well. Mathematically, it fits well. What they wanted to do first with this pseudo space, with all these parameters which condensed into one single data point, was whether or not you can distinguish between somebody who we can say is asleep and somebody who we think is yet to go to sleep, like just going to sleep. And here's where my main criticism of this paper is. I think this paper would have been far better at this point right here if they would have also had a group of people who had just run on like the treadmill for 10 minutes. Somebody who's innervated, somebody who's active, very awake. I don't know, maybe show them a fucking wolf or something. Get their heart rate going.
They could have saved a lot of time if they just, got a bunch of moms in there and their kids, and then the moms know exactly if they're asleep or not asleep. They can tell. I don't know what it is, but we should measure that.
Mom score. They should have added the mom score to the...
Yeah, if you're faking sleep and your mom comes in and you're doing something you shouldn't be doing, that's gonna know.
Well, I mean, everybody knows that women are more tapped into the electro fields of reality, and maybe they're just more in tune with, they're just more calibrated to their child's
psychic
EEG
output.
scores. Yes, their psychic output. But okay, so what they did first was they wanted to verify that their number does distinguish between somebody who is asleep and somebody who is just settled into bed. And it seems like, yes, it does. We can see that there's a decent distinction, but also there's a decent overlap. And that's where the tipping point theory comes in. Like, we would expect the tipping point to be about here. They aggregated it against all the other models.
And that was just based on when their brain waves went from active to what we would consider sleeping brain waves?
No, they worked backwards in this case. So they wanted to know, does this method of condensing information still retain our ontology, our former ontologies of sleep, of somebody who is just settled into bed and somebody who is definitely asleep? Does the way that they quantify it retain the distinction? Yes, it does.
All right.
So then, what they wanted to investigate is this overlap here. How does this overlap happen? When does it happen is also the big thing.
The overlap between when you lay down and when you actually fall unconscious.
Yes. So if you look at the scatter plot that I've got on my PowerPoint, there's like a lot of blue dots mixed in with the orange dots. Do you see that?
Yeah.
So that would be the place where the former models of reality don't map distinctly onto the way that they've quantified reality with a ton of features.
And anecdotally, this would be when you have closed your eyes and you're not fully aware of what's going on around you, and you're starting to slip into that unconscious space, but you could still be awakened by something very subtle.
Yes. And they talk about the accuracy of their experiments, because that does happen. Like, people can jostle awake. I don't know. Like, I
people,
kinda twitch when I sleep.
People have different, paths, or feature paths as they call it, to get to unconsciousness. Like, mine might take 20 minutes, whereas somebody else might take 5 minutes.
Correct. So the group that they developed this model of bifurcation on was on like 70-year-olds. It was on retirees. 1,000 retirees.
No, those motherfuckers fall asleep all the time.
No, they don't. They actually had a longer sleep latency. Their median time to fall asleep with the old dichotomy of awake versus sleep was 50 minutes. The second portion of their experiment used 27-year-olds, like 36, 27-year-old people, and their latency was about 30 minutes.
So as you get older, your ability for your body to go from wakefulness to unconscious sleep takes a lot longer.
Yes, it can. But
Bummer.
that's conflated with things like Alzheimer's, memory problems, sleep apnea, snoring, those sorts of things. And that is actually also reflected in the data that they showed, because the model fits tighter onto the younger people data set than it does onto the old people data set.
Okay.
So there's more variety in the ways that old people fall asleep than young people fall asleep.
Young people follow a more steady pattern.
Earlier and more accurate. We need. This is a science podcast. We need to distinguish between precision and accuracy. Are you familiar with it?
Yeah.
So accuracy is you keep hitting the target in the same place. That's being accurate. Being precise is you hit a bullseye. You hit a 50-pointer.
Yeah.
That's being precise. Now, in science, it's a little challenging to use the word precise because the target is a physical thing.
And you're almost never hitting the bullseye in science.
Yes.
You're getting close.
There's going to be variety.
You're suggesting a bullseye.
Yes, you are suggesting it is a socially constructed bullseye. And that's sort of the problem, and that's why most of the statistics are about accuracy.
Yeah, we have to repeat it and repeat it and repeat it and keep getting the same, not completely precise, but close to result.
Yes.
Yeah.
Okay. So they confirmed that their model does, like the way that they quantified with all these different variables, it still reflects a distinction between awake and asleep. And when they put all that together and then put it on time,
Put it all together.
Put it all together.
Put it all together.
I mean, it's pretty much steady at some point. Like all these data, all these variables, it's pretty much steady.
You know what them science boys been doing down there at that university? They've been coming up with their math numbers.
They've been delving into these numbers, these Lempel-Ziv complexities. I don't even know what the fuck that shit is. Lempel-Ziv, real thing by the way, has a Wikipedia page.
Oh man.
I don't care to look at it. It looks like logic. I don't give a fuck.
I love logic.
So they say that it follows a fold bifurcation trajectory. I mean, this is just like, yes, we found the thing. So their model actually fit very well. Yeah, I need to place myself with where we're going, where we want to be. Okay, so the interesting thing is, once they fit this feature space onto time, they could then calculate where the quote-unquote tipping point is, where the point of no return is. This right here. This point right here.
Yeah.
And they found that when they quantified the tipping point at t time, that when they then went back through the data that constructed at that tipping point and compared it to the current ontology for awake versus asleep, most of the people would be considered awake at the tipping point. And that's sort of describing this right here. Right, you get a lot of
at
people...
the tipping point. Is that like the movie Inception when you have to fall and then you feel that sense of falling and then you can be awakened?
They analogize the pressures on the physiological pressures. They analogize it to falling. Yes. But the way that they use it is they say much like gravity is a field of constant acceleration, there is theoretically a field of constant acceleration due to the circadian rhythms. And based on the distance, okay, so based on their distance from being asleep, they were more able to fall asleep. That I don't quite understand. That result's very technical. I don't quite get it.
What does that mean they were more able to fall asleep?
So they were saying that sleep is closer to a ball falling than to a spring, because a ball falling experiences the same acceleration at every point. It reaches a maximum acceleration, but the time for it to reach the ground depends on its initial state, like how far above the ground it is.
Okay, but in this analogy, would the ground be unconsciousness?
Yes.
Okay, and releasing the ball, would that be the critical point, or would be the maximum velocity be the critical point?
The releasing the ball would be the
laying down in bed?
Yes, it would be.
That's
right
when
here,
it starts
laying
your
down in
path.
bed. Yes.
Okay, and then
Why does it vary between participants, and what's the association with like the tipping point? I don't understand that. Maybe we can work through it together later.
Yeah.
So this is the interesting thing. When they went back through the people who were at the tipping point and went back through the classical model of sleeping, they found that most of the people would be considered awake.
Yeah, because they haven't hit the critical point. It's not till you hit that critical point that you have that instantaneous shift to another state. So as long as you haven't hit that critical point, any point up until that point could be considered still awake.
Yes. And that's why I say, like, I think it would have been really good for them to have another, like, control, like an excited control, rather than their control being somebody who just sat into bed.
Yeah.
As a comparison.
You know what else?
Okay.
I think that they should do a study to see if waking up from a sleep, it follows the same bifurcation model.
Yes, and they mentioned that as well, actually. So this paper is really cool because it confirms a theory with experimental evidence, and basically a couple of the paragraphs in the discussion section are pretty much like, yeah, you know, we should have done this with like people with narcolepsy, we should have done this with people under the influence of drugs. Like, you can use this to a wide variety of transitions in consciousness.
What other transitions in consciousness would we be talking about?
Like under the influence of narcolepsy, under the influence of stimulants, old
Those would
people
still
with
be
Alzheimer's.
I mean, the narcolepsy and under stimulants, that would still be the same. You're going on a path from wakefulness to unconsciousness. It's just not you laying down in bed.
Yeah, it would be you behind the wheel.
You behind the dumpster at a KFC trying to find some chicken wings and not pass out.
Yeah, pretty much. But
That's
okay,
hot.
so there's one other like really cool finding that they had. They found that the occipital lobe fell asleep about 30 seconds before the frontal lobe.
Do you want to hear
And
a
it was
funny
at
story
that-
about that?
What?
Do you want to hear a funny story about that? I have a
You don't
little
have an
story.
occipital lobe? You don't have a frontal lobe?
No. In veterinary preschool, that's a funny way to say that. In undergrad school, I had an anatomy teacher. My anatomy teacher was from Italy, and she pronounced all of the anatomical parts in her own special Italian way. And so when I started to pronounce anatomy around colleagues that did not go to the same school as me, they thought I was a fucking idiot because I kept saying the occipital lobe
The occipital lobe.
and the buccal cavity instead of the buccal cavity.
Okay, but that one's permissible though. Like buccal cavity, people are gonna understand.
Yeah, the occipital lobe.
Nerd. So the interesting thing is that it almost looks, so the occipital lobe is in the back. Frontal lobe, it's in the front. The interesting thing is it looks like it almost follows the opposite direction that wakefulness does. So they're saying that sleep starts in the back, and over the 30 seconds, it collapses the rest of the brain into sleep, assuming nobody jostles you up. But the way that your homeostatic processes work is you've got a very, very just amazing, I would say, like genuinely, like the chances of this developing due to chance, much less life itself existing due to chance, this regulatory clock existing due to chance, slim to none. Atheists seething yet again. You're not an atheist, are you?
Oh yeah, big time atheist.
Are you seething?
I'm not seething.
I don't think you're impressed enough with the BMAL clock. Essentially, the circadian rhythms are one of the major things that regulate your sleep cycle, and basically your genome will express these two proteins that will combine together, and then they'll induce another set of proteins, these CRY and PER, which will then inhibit expression of BMAL1 clock. So essentially, like, throughout the day, your levels of BMAL and COC increase, and then also increase the CRY and PER, which then decrease your BMAL1 clock. That's also regulated by your brain, your diet, your cortisol, your melatonin, and your adenosine. Lots of factors going into the sleep that they were not able to measure. So they were able to measure like melatonin, internal temperature, and cortisol, I think? Yeah. But that's the setup. That's how they found the model. And while I was reading this, I was like, okay, hold on, guys. Hold on. What are the major factors that you would blame on this, right? Because we've got all of these, they had like 60 or so features. Which are the big ones? Which ones have the explanatory power? And they actually said it. They said that the max beta frequency, the spectrum centroid, oh god, this one again, the Leville Ziv complexity, the dwelling time, the total spectrum, and the spectral slope. I have no idea what any of these mean, except for the max beta frequency. That's just one of the EEG waves. So they were able to reduce the data set into a couple of explanatory features, but they actually lost a lot of accuracy. Especially when it comes down to the individual level. Salty, are you with me?
Yeah, I'm looking at the laryngeal nerve of giraffes that runs all the way up their neck and through their spine and back down, which is a perfect creation of God.
That's kind of disgusting. An artifact of evolution.
Hey, he said evolution. Let's go. We win.
Yeah, but you can't prove the past, idiot.
I don't have to prove the past. I'm living in the future.
You think fossils prove evolution? No, that's a snapshot of time. Sequence every fossil then, huh? How about that?
Well, no, I mean, you still have to go the mechanism, and the best theory right now is natural selection, but even that theory is not foolproof.
Yeah.
It's a working science.
Yep. So after they figured out what the major explanatory variables in their dataset was, they moved on to reality testing the model. So this is down towards. So no. If you go to figure 3, that's where they've got the explanatory figures. You've got the peak beta frequency, total spectrum power, their respective like sleep distance, and its association with their like the total dataset score.
Yeah, I'm there. I see it.
In the rainbow. So these variables, like not perfect, not like a perfect one-to-one line. There's like a little bit of like a bend up and a little bit of a bend down. And then the negative ones, so these have like an anti-correlation, are the theta temporal coherence and the delta to alpha ratio, among others.
Which was the main two things they were using.
Yeah, so these are the variables with the most explanatory power within the 65 or so features that they mapped.
Okay.
To generate this one piece of data to say whether or not this person's asleep. So they then used this model to attempt to predict when somebody would fall asleep. And and they were able to do it relatively well.
And so what does that tell us?
So this was in the younger cohort of people with the tighter like accuracy.
Oh, the younger
model
people were
to
tighter?
data.
I'm so surprised.
Yeah, I know, it's crazy.
Not like those loose old floppy grandmas. Nerves are flopping
cognitively
all over the
loose.
place.
Cognitively loose and floppy.
Neurotransmitters are spilling into the fucking empty spaces of their brain.
Actually, give me like 50 AI sloppers and like 50 kindergartners and show me the bifurcation dynamic between the two. Compare and contrast.
AI sloppers are at like an hour and 50 minutes, I bet.
Yeah. So they essentially like calibrated the model to individuals and then tested it over a ton of training nights. So like each participant came in about 7 times, and the prediction was relatively well.
That's quite a bit of data, to be honest.
And the tipping point, the median tipping point was about 3 minutes earlier than our former model of sleep.
But the former model was based on the old people.
The former model was based on old people. The former model generated an accurate function to chart essentially the descent into sleep. That
Yeah, it
descent
gave
into
them a good
sleep-
baseline, and then the young kids beat them out of the fucking park with their sleep times.
Yes. But the important thing is that, so I guess this is very complicated because the former models of sleep are very ordinal, very yes or no. The one that they've got now is distributed. So if you look at figure 4E, there's a distribution of tipping points. And the median tipping point for these younger people was 3 minutes before the former older models would say, okay, this person is asleep.
Yeah, I see that.
And it was highly accurate.
Nice.
Yeah.
You know what they need to do for their next study? They need to combine the
What?
last study that we looked at and this study and see how drinking
Yeah.
coffee and caffeinated coffee specifically affects your path towards unconsciousness.
It would be really cool.
I
But,
bet
like,
it.
don't
I mean,
even look
obviously,
at,
it's going to extend it. It's going to make your path longer, but like how long? And you know, how does that affect
How
your
about,
sleep?
How about like no screen time an hour before bed?
I need to get on that train, bro. I'm so bad about that.
Same. That was one of my New Year's resolutions. Has not turned out phenomenal.
Well, I'm one of those people that like I have to listen to something in order to go to sleep, so it's even worse for me. I've got YouTube running all night.
Yeah.
My poor wife.
Okay. So the final thing that that I'd like to touch on that I don't quite understand is this. The authors say in the discussion section, we show that the occipital brain regions displays an earlier sleep bifurcation tipping point and a larger bedtime sleep distance at bedtime than the frontal region. And this is a pretty consistent association that they find. A larger bedtime sleep distance is associated with an earlier bifurcation sleeping points.
Okay.
And they say, it may seem counterintuitive. They say, our findings suggested that an earlier sleep bifurcation tipping point is associated with larger sleep distance at bedtime. And the frustrating thing is that they acknowledge wakefulness is not arousal. So like, we would expect larger sleep distance at bedtime to associate with like arousal. Like you're more awake. Somehow that means that you fall asleep faster.
That's interesting.
So they say, however, a larger sleep distance at bedtime reflects a brain state further from sleep, but not necessarily a brain state closer to arousal. because it's a multi-dimensional space with a ton of factors that have been compressed into one.
Yeah.
Additionally,
so,
an earlier bifurcation tipping point reflects a longer bifurcation transition process, but not shorter sleep latency.
so people with a shorter path are easier to wake up.
No, they don't examine how people wake up, which would be another cool thing.
Yeah, like if people have a short path to unconsciousness, are they easier or harder to fall out of that?
Yeah. So, I think what they would say is that it's easier to fall out of it. Like,
Yeah, that's what
you
I'm-
would
I think
probably
they're
be more
saying.
restless. So they continue, quote, the dependency of the bifurcation tipping point time on the sleep distance at bedtime may suggest a distance-independent acceleration during the bifurcation. A larger distance takes longer time and therefore is associated with an earlier bifurcation onset. But like, okay, if you've, because they analogize this to falling asleep in the next sentence. And like, if you've got a larger distance, it would be a later time point to hit the floor.
Yeah.
They say the wake-sleep bifurcation kinematics resembles the kinematics of a falling body, which is characterized by a constant acceleration and a falling time that depends on the initial distance, thereby supporting the subjective sensation of falling asleep. This type of kinematics does not resemble the kinematics of a spring. But like, I feel like they didn't explain that very well at all.
I agree. Because
I
I
don't
don't understand it.
Like, independently, I guess like the challenging thing is that they define the mathematical variables very early on, but they only define sleep onset latency in the discussion section.
Yeah.
So when they say like,
I mean, I'm not gonna get into their calculus and try and judge that.
yeah, I wish they would have used a different word than bedtime, I guess. So they say the dependency of bifurcation tipping point time on the sleep distance at bedtime may suggest a distance-independent acceleration. But like, this is a clumsy sentence.
It's kind of subjective.
They use time 3 times.
Say time again.
Me. I don't understand what this is like the main, like, one of the main, like, outcomes that they found in this study. I don't understand it. The other like main outcomes that they found was the principal component analysis, like the features that most drive the bifurcation, and then the accuracy of the younger cohort against the older cohort, and finally that the occipital, the back of the brain, falls asleep before the front of the brain.
Yeah, that's all interesting. The other interesting tidbit that I pulled out right here is sleep onset disturbances are more common in older adults, which we already established, but that they are also associated with an increased risk of Alzheimer's disease. So if you are easily disturbed when you're trying to go to sleep, you should get yourself checked out.
Or just take melatonin. But like the problem, like, I guess like the thing is like get a red light filter or a blue light filter rather. Get off your phone, take melatonin, I don't know, smoke weed or some bullshit.
Whoa.
To help you fall asleep.
Are you pushing drugs now?
This is beak to beak.
I thought I was the atheist pothead in this relationship.
Capital singularity. Salty
Oh my
squared.
god. I'm supposed to be the pothead crazy one. You're supposed to be straight and narrow.
What? You oscillate highly rapidly between I'm the crazy one and you're the crazy one. It just doesn't make sense.
I think we're both crazy.
Okay.
What's your
let me see
straight
if I
jacket
can-
size?
My straight jacket size? I'm kind of a petite. Like, the feathers really like give a lot of volume that's unjust.
I wonder if we got
I
an extra
do.
large, if we could both slither into the same one.
Ew. The same straight jacket? That would be kind of a cool, like,
I'm trying to save money here.
logo. That would be really cool. It's both of us in the same straight jacket.
Straight jacket.
Stop, you're poking me with a pin feather.
Oh
It's
man.
not my fault.
I'm sorry I inked
Is that
all
your
over
beak
you.
or your
It's...
your tentacle?
Oh, don't. You don't want to know.
Okay.
Back to business.
So I've asked Claude to parse apart that sentence.
Oh my fucking
this portion
God.
of it that I'm struggling with.
We are expressly anti-AI on beak to beak / twin beak / whatever the fuck we call this.
You're so full of shit. You're so full of shit.
No,
Tyler.
no, we cannot allow the techno feudal lords to corpo rape us into the ground.
Okay, so it's synthesized. I asked it a bunch of questions about bifurcation dynamics. Gave it a couple of publications to parse through. I calibrated the model. Okay. And here's what it put out in plain English. Quote: no matter how awake you are when you go to bed, your brain heads towards sleep at the same speed. So if you're very alert at bedtime, it takes longer, and that longer journey means you are already on the path earlier than someone who started close to sleep. Okay.
How the fuck would this fucking AI know?
I don't know
This
that-
is like cutting edge science. Did you pop this paper in there?
Yes, I've got Claude attached
Oh my
to
God.
Consensus AI.
It knows too much now.
I have been waiting for an LLM model that does not hallucinate papers, 2, that actually can like parse through publicly available papers, and then 3, can access like supplementary data so that I can peruse it at my convenience. But this is the one part that I struggled with, so I wanted to ask it.
I mean, the worst I do is I let a PDF reader read it to me. So I can garden while I'm listening.
You let a PDF reader do that? You just listen to the Dispel Marketable show, which is what I do. I let a PDF reader just read to me a paper.
I mean, I still read it myself later so I can look at all the data and the graphs and shit, but I do, the first run of the paper that you give me is usually the PDF reader just yelling it at me.
Oh, it's when the tipping point occurs relative to bedtime. That's right.
Oh!
Because
Oh!
it's anchored on the former model of sleep, where when people are going to sleep, it's different than the bedtime metrics. So it's sort of like the tipping point is constrained between those two variables, and people come filtering into the study with different levels of arousal. And what they're saying is there's a constant, once you're settled in for bed, there's a relatively consistent in healthy adults, there's a relatively consistent draw towards sleep. And I think in order for the, I guess this is actually, I guess I did intuit the what the sentence meant relatively well, because again, they do not test this in people who are aroused when they go to sleep. Put somebody on a treadmill for 15 minutes, plug them into the EEG and have them go to sleep. If I understand what they're saying to be true, we would expect them to fall asleep at the same speed, but the tipping point would be later?
That's weird, so their body compensates for how aroused they are and speeds up the process at which they fall unconscious?
No. They're saying it happens at the same rate between people. Like, there's obviously interpersonal variability, but between people it happens at the same rate. What matters is your initial point. And that's what I'm saying. Like, if they want to make this sort of statement, I think they should have tested it in a third group of people who were aroused before they went into sleep, instead of whatever random people who got checked in, bored out of their mind with paperwork, forms, and consent.
Yeah, that would have
Before
made
they got hooked
an excellent extra data set.
Yeah. Okay, hold on. If the rate at which sleep distance decreased... By the way, okay, so a decreasing sleep distance means you're getting closer to sleep, closer to unconsciousness. So if the rate of becoming unconscious depended on how far away you were from the tipping point, you would expect a faster descent from a higher starting position. And everyone would arrive at the tipping point at a roughly the same clock time. But the authors say that they observe the opposite. A higher starting position is associated with an earlier tipping point. This means the system is not pulling harder on people who are further away. Instead, the descent appears approximately consistent regardless of the starting distance. And I'm saying, if they wanted to prove this, they should have had another cohort of people who came in experimentally manipulated to be excited.
Well, maybe that's their next study.
I hope so.
That's usually how these things go. I mean, at the end of the study, they usually say what they could have done better and what they intend to do in the future.
Hold on. Maybe they've put something out. Let me check really quickly. Nope, they've got nothing else. Nothing newer. Or how do I sort by fucking date? Oh, date published. I'm a hater. I am a hater. I am a hater.
Oh, good.
I'm a
Are
hater,
you my hater? Because
I'm a
I love collecting haters. I need more of them.
I'm not a hater of you, though.
God damn it.
Hmm.
I guess so.
It's still not sorting by fucking date. Update results.
I'm
Okay,
smoking a
I
joint
didn't
now,
have it
by the
there.
way.
Okay. Yeah, no. So after they publish the study, no, they've got no further developments on it. At least, like, the PI does not. Maybe the main author does?
I wonder if they intend to do more studies in the future along this lines, though.
My bet is that the Trump administration cut their budget.
That's what I was thinking too.
That's where my
I
money
mean,
is.
we're so
Oh,
down. We're so down
Wait, never
bad in
mind.
the science community right now.
Wait, actually, it's funnier than that. Salty, get this. Their lab is actually in the UK.
Oh no! Well, we have to take all of this data with a grain of salt then, because
So actually, they've got no excuse.
for their science being stifled, yeah, no.
Yeah, for not putting out a follow-up paper where they introduce another experimental group.
They do have
With
the excuse of
a
being European though,
arousal.
and that's just like, yeah, you gotta give them a mulligan on that one.
They're not European. They are not European.
The UK is
Let's-
not European. Oh, I guess not, huh?
No, they're like American.
They're basically offshoot of America.
Yeah, they're basically American. Anyways, yeah, that was great. You picked up onto systems theory like very rapidly, just like through reading the paper.
Yeah, I'm a smart guy.
I'm smoking this shit down. I'm getting dumber by the moment.
You're not wrong, brother. You're not wrong.
What do we got going on next week? Quote, personalized brain circuit scores identify clinically distinct biotypes in depression and anxiety.
All right. I love anxiety. It's my best friend. I carry it with me every day.
Well, this is gonna be awesome. You get to learn about fMRI.
I know a little bit of fMRI. I think.
Do you?
Maybe.
You probably do. You probably put a couple of animals through MRI. Just
No, I did a lot of
Functional MRI,
CT
right?
scans, not functional MRI.
okay, yeah. Fuck you, salty squid. Okay, hold on.
All right. Anyway, that was Beak to Beak. Thanks for joining us. I've been Salty Squid. This has been Pigeon, also known
Bye-bye.
as Dispel. You can find him at Dispel Marketable Archive on YouTube. You can find me at Salty Squid Stream on YouTube. Please like and subscribe. Press all the buttons, or don't. I don't really give a shit. I love you anyway.
Get smarter. Get smarter every day. Get your learn on. Get drowned.
Oh yeah, don't drown in the unknowledge sea.
The sea of ignorance.
The sea of ignorance. Oh boy, couldn't be me. Could not be me.
Not us. Not us.
I only swim in the shores of enlightenment.
Together, hand in hand, or rather, claw and tentacle. Ew. Kind of disgusting.
Cut!
Twin Peaks. You know it's time to get the lab coat on. Twin Peaks, yeah, cause we out here being hella wrong. Twin Peaks, and you know we're never stopping till the hammer drop.